Alright, example number 4. I will consider this example as one of the hardcore questions that you may see on your quiz. Well, once again, your quiz will be open notes, open homework, more like a worksheet where you would just rely, basically you are still treat it more like a quiz, but you have your homework, you have your notes in front of you as you are to do your worksheet. But here in example 4, I will consider this questions as probably one of the most difficult questions that you may see on your quiz, where they don't give us numbers. They are just telling us that here we have a triangle. Emily, you have a questions? I have a triangle PQR. They are not giving us the coordinates for these 3 points. And this is just any triangle. I don't know the type of this triangle. It could be scalene triangle, it could be isosceles, it could be equilateral. So to make it more general, I'll try to position my triangles more like a scalene triangle. You need to start your triangle somewhere as your first point, and that I can probably make my questions easier by having one point at the origin. This point gives us some really nice numbers to work with. 0, 0. There will be another random point for point Q, and it doesn't matter where I pick my point R, so long that it ends up with a scalene triangle. I can put point R anywhere on the graph, but once again, to make my questions a little bit easier to deal with, maybe I would choose a point on the x-axis. So let me go with a point here. These 3 points will give us a scalene triangle. It looks like a right triangle, but it isn't. Or if you don't want to consider that as a right triangle, just position these points a little bit differently to make it not look like a right triangle. While we don't know the coordinates for point Q, you probably would know the y coordinate for point R. And that's one of the reasons why I pick a point on the x-axis. The y coordinate for point R will be 0. We make it that way to simplify our calculation. And at the same time, let me consider the x coordinate as R. And for the point Q, I need to create some other random variable for this. And I will try to stay away from x and y, because sometimes we use x and y for line equations. We are not dealing with line equations, we are just dealing with some random coordinates. What do you want to use? Doesn't matter. Anything. Anything? A and B, sure, why not? So if I have a triangle with points P, Q, and R, this triangle will look something like this. Once again, it is not a right triangle. It looks like it, but it isn't. And they are telling us that we have a point K being the midpoint of PQ. If this is the midpoint from P to Q, I can then calculate the coordinates for this midpoint. I can figure out the coordinates, the x and y coordinates, by taking the average of the x coordinate, add up the x coordinate divided by 2. That will be the x coordinate for point K. And I can do the same thing for the y coordinate. I have 0 and b for the y coordinate. Take the average of those two. I will end up with b over 2. Totally fine with that. I have no problem working with fractions. So I have point K being a over 2 and b over 2. K is at this point. I don't have numbers for a and b, but doesn't really matter. And then there is a point L, halfway between P and R. If this is a point, if this is the midpoint on the line PR, I can do the same thing, calculate the x coordinate of the point L by taking the average of the x coordinate. Add those up divided by 2. That gives us the x coordinate of point L. And I can do the same thing for the y coordinate. And this is pretty easy. You don't need to calculate this. You can probably read it off on your graph. And this will give us the coordinates for point L. We have coordinates r over 2 and 0. Once I have the coordinates, I can start to do some work. Show that the line from K to L is parallel to Q to R. Here is the line they are talking about from K to L. And here is another line they want us to work with, Q and R. They want us to calculate the slope of these two lines. And hopefully they are the same. Well, technically they should be the same, but we need to show the work. So in this case, let me calculate the slope between Q and R, K and L. These are the two things that we need to work on. We can find the slope between 2 points using the slope formula. y2 minus y1 over x2 minus x1. It is totally fine if everything is in terms of some random variable. We know how to simplify it. And between K and L, the slope between the 2 points, we have y2 minus y1 over x2 minus x1. The numbers looks a little bit more ugly, I'll say, but hopefully it will simplify to something really nice. When you take a look at these expressions, seeing how everything comes with a denominator, I can eliminate the denominator by multiplying the top and bottom of these fractions with a 2. And that will easily eliminate the denominator on both the numerator and denominator. And here we have the same slope. So this is kind of like something that we've done back in rational expressions. When we had to simplify rational expressions, we were talking about how to eliminate the denominator in your expressions. And we can simplify it that way. So in this case, since they give us the same slope, we can then conclude that the two lines are parallel. Since the slope QR equals the slope KL. Therefore, those two lines are parallel. This is one part of the question. We've done that these two lines are parallel. And if you go back to the question, there are more to it. They want us to show that the length of this line is half the length of the other one. Or in another word, if I'm to multiply the distance on this line by 2, it will give us the distance there. That's what they want us to do. And when it comes to distance, it should be pretty obvious that we need the distance formula. So here, set up distance formula, find the distance from Q to R. Once again, we don't have numbers to work with. But we can come up with the difference of the x coordinate and then the difference of the y coordinate, simplify it. And that probably simplifies to something like this. That's the distance from Q to R. The distance from K to L, we got some coordinates that come with a denominator, but things will still be pretty much the same. Set up your equation using the distance formula. I have x1 minus x2 square plus y1 minus y2 square. And hopefully this line will give us half the length of the other one, of the one that we've done. Well, seeing how those coordinates, they all come with a 2 in the denominator, maybe I can simplify it a little bit. Maybe I can take it out as a common factor. And when you are to take out the 2 as a common factor from a perfect square, you are going to see that number coming out as a quarter. When you square the denominator, that's how you end up with a 4. And seeing how we have a quarter here and a quarter there, if I continue to factor out the 1/4 from both of them and put it at the front, the square root of 1/4 would then give us 1/2. And that will give us a similar expression as in the one that we saw. Here is the distance for QR, and now the distance of KL is in fact 1/2 of the distance we saw in this case. So here we have successfully proven that the line from K to L is half the length of the line from Q to R. So once again, this is the type of questions that I will consider the most difficult in this unit, because you don't have numbers to deal with. Everything is in terms of different variable. Now once again, your quest on the third or the second, whichever comes first, will be open notes, open homework, and many of the questions on your quest will be similar to your homework. I'm not going to make my life too difficult. I probably will try to come up with things that are very similar to your homework. So if you can do your homework for this unit, well, I have those homework on the website already. I've uploaded all the lessons from 1 to 4 with the homework for each lesson as well. If you can complete the homework, you should have no problem doing well on my quest. And mind you, the homework for today's lesson, when you take a look at the answer, there are only a few of them that comes with answer, because the rest of them, they already have the answer given to you. It is just a matter of showing them that the answer is correct, that you are getting the same conclusion as given in the question. So make sure you do your homework. And I will stop here.